Okay, welcome to another radiography review video. This will be part one of a two-part series of videos talking about setting technical factors on our control console. This video is going to pretty much just be about milliamperage and time, and I'll make a second video to discuss kVp. I'd like to talk about mass, milliamperage times time, first, because at least for my students' purposes and the way I approach setting technical factors, I prefer to set mass first and then set kV second. I know as a student this always was one of the things that was very intimidating to me, was the use of the control console, because it seems like there's a lot going on here. But really, when you boil it down, there's just really two main things happening here on the control console. You're setting a strength for the X-ray beam and a quantity of X-rays to be created. So the quantity of X-rays being created comes from the milliamperage and time you make the exposure for. We know that in the X-ray tube we have a high potential difference from cathode to anode, which we generate a space charge of electrons. Those fly across the gap from cathode to anode in the tube, hitting the anode and decelerating the electrons, generating X-rays. So we control all of that from our control console. At least we control quantity. Mass, again, refers to the quantity of X-rays created during an exposure, and it's more of a relative quantity. You could take the time to sit down and do a calculation on how many X-rays might be created, but we're talking about as relative number of X-rays. By that I mean that mass changes work direct and proportional to the number of X-rays. That is, if you double your mass number from, let's say, 5 to 10 mass, you've doubled the number of X-rays created during that exposure, because you've done things like doubling the number of electrons freed during the high potential application on the X-ray tube when you press the exposure button. Or you double the exposure time, that'll double the amount of time you allow the electrons to travel from cathode to anode for. This video is on making the mass calculations. Mass is just milliamperage times time in seconds, so mA times S equals mass. We get our mass number, we take our mass number from our technique chart, which every X-ray room has a technique chart. Some equipment, like AEC, you'll set like an mA, okay, which tells you things like your focal spot size, and you won't know the final mass until the exposure terminates. There'll be like a backup mass number, but on older control consoles, such as this one, and even some that are APR, anatomically programmed radiography, we have to set our own mass. Okay? So let's start off with a quick, easy calculation. 100 mA times 1 second, 100 times 1, mA times time, equals 100. So 100 mA for 1 second is 100 mass. So take a look at what that means. Anytime you multiply something by 100, you take whatever decimal point, wherever the decimal point is at, and shift it over 2 places to the right. Okay? So this is 1.00. Shift the decimal point 2 places to the right, it becomes 100. And you can do that for any one of these settings on here. So a common setting for, like, let's say a hand or wrist or foot, for example, might be 2.5 mass. Well, I can make 2.5 mass pretty easily by multiplying 0.025 by 100 mA. Okay. I could also make that same setting by 2.5 mass, same setting, by doubling the time and halving the mA. Okay. This is called the law of reciprocity. The way I tell my students about the law of reciprocity, how to think about it, is mass is mass is mass. However you set your mass setting, the number is the number. If you want to make 2.5, however you get me to 2.5, that's the number. Okay, that is the mass number. So if I want to set, let's say, 10 mass, I start at 100 mA, and I go to 1/10 of a second. I move that decimal point 2 places to the right, that equals 10.0. If I also wanted to set 10 mass using a different mA, I could increase to 200 mA and cut the time in half. All of these changes are direct and proportional, so you can double MA, halve the time, and that would equal the same mass as what you originally started with. So that's the basics of mass calculations. For the second part of this, the KVP calculations, please follow up on my next video where I'll discuss setting KV and making KV adjustments. Thank you.